In this physics problem, we need to find the condition for two particles to collide. Let's look at the problem. Two particles, 1 and 2, move with constant velocities v1 and v2. At the initial moment, their radius vectors are equal to r1 and r2. How must these four vectors be interrelated for the particles to collide? To solve this problem, we need to determine when the positions of the two particles will be the same at some time t. Let's start by visualizing this situation with a diagram. Let's represent the initial position of particle 1 with radius vector r1, and the initial position of particle 2 with radius vector r2. Particle 1 moves with constant velocity v1, and particle 2 moves with constant velocity v2. These dots represent our particles. Let's set up equations for the position of each particle as a function of time. For particle 1, its position vector at time t will be r1 plus v1 times t. Similarly, for particle 2, its position at time t will be r2 plus v2 times t. For a collision to occur, the two particles must be at the same position at the same time t. This means r1 of t equals r2 of t for some positive value of t. Let's substitute our position equations. We get r1 plus v1 times t equals r2 plus v2 times t. Rearranging, we get r1 minus r2 equals v2 minus v1 all times t. Let me animate this to show you what happens. The particles will follow their respective paths based on their initial positions and velocities. Notice that they will only collide if their paths intersect and they arrive at the intersection point at the same time. Let's find the exact mathematical condition for a collision to occur. We define delta, r, as the vector from particle 2 to particle 1, which is r1 minus r2, and delta, v, as the relative velocity, which is v1 minus v2. For a collision to occur, the particles must meet at some positive time t, which means delta r equals delta v times negative t. This implies delta r must be parallel to delta v, meaning they are scalar multiples of each other. Let's visualize this geometrically. Here's delta r, the initial displacement vector between the particles, and here's delta v, the relative velocity vector. For a collision to occur, these vectors must be parallel and in opposite directions. We can express this mathematically as delta r equals k times delta v, where k is a negative scalar. To summarize, for two particles to collide, the vector from particle 2 to particle 1, delta r, must be parallel to and in the opposite direction of their relative velocity, delta v. Mathematically, we can express this condition as r1 minus r2 equals k times v1 minus v2, where k is negative. This ensures the particles will meet at some point in the future.